You know, every single thing we do online, every click, every message, every purchase creates data. And all that data needs a home. For a long time, there have been two totally different blueprints for building those homes. So today, we're diving into those two rival philosophies, the super structured world of SQL versus the wild, flexible world of NoSQL. On one side, you've got SQL. Think of it as a world of perfect order, built on structure and predictability. And on the other side, NoSQL, a world literally designed for chaos, for incredible speed, and for massive, massive scale. As we're about to see, this isn't just a technical decision. It's a whole philosophy about how to handle information. Okay, so let's start with the original champion, the one that started it all, the established world of SQL. Its power, its whole reason for being, comes down to one single powerful concept: relationships. SQL, which stands for Structured Query Language, is basically the universal language for talking to these things called relational databases. The easiest way to picture them: imagine an incredibly organized warehouse full of neat, perfectly labeled boxes. We just call them tables. Let's see that order in action with a simple accounts table. See how every piece of information has its own special spot in a column, and each of those columns has really strict rules. For instance, the account ID has to be totally unique, and the creation date must be a real date. This is how SQL enforces the rules from the very beginning to keep all the data clean and consistent. And this is where the real magic of SQL happens. That country ID in our accounts table, it's not just a random number. It's a link, what we call a foreign key, that connects directly to a completely separate country's table. This is what lets us ask incredibly powerful questions like, hey, show me all the accounts from the USA, by just joining those two tables together. It's pretty brilliant. Now here's the crucial part. SQL offers you a guarantee. It's built on something called the ACID properties. It stands for atomicity, consistency, isolation, and durability. But what that really means, in simple terms, is that a transaction, like a bank transfer, is all or nothing. It either happens completely and correctly, or it doesn't happen at all. It can't get stuck halfway. This rock-solid reliability is exactly why SQL is the only choice for financial systems, for accounting, really anywhere that data integrity is absolutely non-negotiable. For a long, long time, this super-structured universe was pretty much all we needed. But then the internet happened. And with it came this explosion of data that just refused to fit into those neat little boxes. And this created a whole new kind of problem. I mean, what do you do with the massive, unstructured flood of information coming from social media feeds or user clicks or all those new IoT devices? This is data that changes so fast you can't even define a rigid structure for it ahead of time. SQL just wasn't built for this new, messy reality. And that exact challenge gave rise to a totally new way of thinking. A world designed from the ground up for flexibility and scale. A world that we now call NoSQL. So, NoSQL, which really means not only SQL, is a whole family of databases that basically just threw out the rulebook. A lot of them are schemaless. Think about it this way. While SQL makes you design every single column in your table before you can put anything in it, NoSQL just lets you toss a document in, even if its structure is totally different from the last one. This kind of flexibility is an absolute game changer for apps where the data itself is always changing. But maybe its biggest superpower is how it scales. See, SQL databases usually scale vertically. That means you have to buy a single, bigger, more powerful server, which gets expensive fast. NoSQL scales horizontally. You just add more standard, cheaper servers to a group or a cluster. It's like adding more lanes to a highway instead of trying to build one single, faster car. This makes it almost infinitely scalable for modern web traffic. Now, NoSQL isn't just one thing. It's actually an umbrella term for several different kinds of databases, and each one is optimized for a very specific type of job. First up, we've got key value stores. These are the simplest of the bunch. Just think of a giant dictionary. You have a unique key, and it points to a value. That's it. Because they're so simple and often run right in memory, they are unbelievably fast. This makes them perfect for things like caching, storing frequently used data to make your website load in a flash. Next up are document stores, and these are probably the most popular type of NoSQL database out there. In these, data is stored in flexible, self-contained documents. So all the information related to one single item, like a user profile with all their contact info and preferences, is kept together in one place. This makes it super efficient to read all the data you need for a common task. Then you have the heavyweights, wide column stores. These are the beasts. They're designed to be spread across hundreds, maybe even thousands of machines. Imagine trying to log every single click on a website like Google or Facebook. That is a massive fire hose of incoming data. Wide column stores are built for exactly that kind of insane workload. And finally, we have graph databases. These are all about the connections between data. They store things as nodes and the relationships between them as edges. This is the technology that powers your social network, mapping who's friends with whom. And it's what's behind those e-commerce recommendation engines that say, hey, customers who bought this also bought. Okay, so with all these different options, how in the world do you actually choose? Well, it really just comes down to one thing: matching the right tool to the right task. This table breaks it down perfectly. You're going to lean towards SQL when your data structure is predictable and rigid, like for user accounts or financial records. Its absolute superpower is data integrity and the ability to ask complex questions later. On the flip side, you'll choose no SQL when you're dealing with messy, evolving data, and your main goals are just blistering speed and massive scale, usually by looking up data with a key you already know. But here's the real secret in today's world: that whole versus debate is kind of outdated. The most sophisticated modern applications don't make an either-or choice. They use a hybrid approach, taking the absolute best from both worlds. Just think about any e-commerce site you use. As you're browsing around, clicking on products and adding things to your cart, all of that temporary session data is fast-moving, it's messy, it's unstructured. It's a perfect job for a NoSQL database that can handle that huge volume of writes without breaking a sweat. But the second you click that buy button, everything changes. Your final order, your payment information, the inventory updates, these are critical multi-step transactions that absolutely cannot fail. That data gets sent to a SQL database to make sure the entire transaction is reliable, consistent, and accurate, down to the very last penny.